Hey guys, in this video we're going to talk about the cotangent graph, and we're going to use the tangent graph from our last video to help us with this one, because the relationship between cotangent and tangent is simply that cotangent is the reciprocal of tangent. So what we're going to do with all of the values from our last lesson is we're going to take all of those values and just flip them, and you'll be able to have your cotangent values and graph those functions. So I'm going to bring back our values from the last page, right? We should all have those filled in. And this is what we had there. So when I did tangent at pi over 6, our result was square root 3 over 3. Now, I did rationalize it, but if you were to take that back before it was rationalized, I know that's little, but 1 over the square root of 3 is what we had there. And really, that's going to be the easier value to flip. So if I were to take 1 over the square root of 3 and I take the reciprocal of that, it becomes square root 3 over 1, which is just the square root of 3. So for the cotangent of pi over 6, that's what we'll have. And this was it as a, no, I'm lying to you. Sorry, this one as a decimal was 1.7. So I was reading the wrong one that I had on my paper over here. Okay. So that'll be easier to graph if we look at it as a decimal. Pi over 4, let's look back at what that was. From your tangent function, that was 1. Well, if you take the value 1 and you flip it, 1 over 1 is still 1 over 1, which is 1. So that's easy. Square root of 3 is what we got with pi over 3. Take that and flip it, it becomes 1 over the square root of 3. You can rationalize that to become square root 3 over 3, just like we did in the last one. If you leave it like this, it's okay. Really, again, that decimal is going to be the easier one to graph. So, all right, then look at pi over 2. Pi over 2, if you remember, that was, we did sine over cosine, 1 over 0, and that's how we got undefined. But for this one, it's got a flip, meaning it would be 0 over 1. So our answer in this case is actually 0. So keep in mind that when you're doing all these reciprocals, the reciprocal of undefined is 0, and the reciprocal of 0 is undefined. I want you guys to pause the video and go ahead and fill in the rest of this table for me, okay? Come back when you're ready to check them. All right. Let's go through and see what these values should have been, guys. If you did this, this should be negative 1 over root 3, negative 1, negative root 3, and then undefined. And if you filled out both tables, you probably noticed that both tables end up being the exact same thing. So you can just copy them down. It ends up being the exact same math, so it doesn't really need to be done all over again. All right, let's talk about graphing these guys. Now, this graph grid's scaled a little bit different than the one that we had on the tangent graph. That's okay. First thing I'm going to do is look at pi over 6, which is halfway between 0 and pi over 3. And then my output is supposed to be at 1.7. So we're looking at a roundup in here. The next one is pi over 4, 1. Well, I don't see pi over 4 marked, right? This was pi over 6 right here. Pi over 4 is halfway between the pi over 6 and pi over 3. So just keep that in mind as you graph. The pi over 4 on this graph grid is not going to be on a line, but that's okay. Pi over 3, we're supposed to be at 0.58, so a little more than halfway to 1. And then at pi over 2, we're supposed to be at 0, and pi over 2 would be here between these two values. Keep on going. 2 pi over 3, we should be at negative 0.58-ish. 3 pi over 4, again, that's not going to be on a line. It's in between those two. Then we get 5 pi over 6, should be in this line, down at about 1.7-ish. Oop, right in here. And then at pi, our output is undefined. And if you guys recall from our video on the tangent graph, every time we got undefined like that, it actually resulted in an asymptote. So we're going to see that vertical asymptote that goes through here. And you guys can mark that with that dashed line. I do like to see those on the graphs when I'm grading. I think that's helpful. All right, now all these values end up repeating themselves. So it's basically like we're going to get this same pattern, just repeat itself over here. So here at 7 pi over 6, we're going to be up at the 1.7-ish again. Then we'll be at 1. We'll be at 0.58. So if you need to go back and take this a little bit slower, feel free to go back and, rewatch this. But you get the same outputs here. You can go ahead and connect everything. Yeah. And at the end, when you get to 2 pi, the output was undefined again, which means we have yet another asymptote. Another value, I always feel like they need to add these, but they don't. Another value that would be good to add is to look at the input for if your x was 0. And if your x is 0, I want you guys to remember back to what we had on the tangent function. But on the tangent function, when my input was 0, my output was 0. The reciprocal of 0 is 0. So as an added bonus, the reciprocal of 0 is undefined. I'm sorry. Y'all, I haven't had my coffee yet this morning. But yeah, so this should be undefined. And so we end up with another asymptote on this value. Okay. These values can repeat themselves. So as you just get an infinite number of this pattern over and over and over. They want to know how long one of the cycles is. Well, if you count from the beginning of one cycle to the end of it, that's pi units. So the period of cotangent is pi. There is no minimum or maximum point. And if there's no minimum or maximum, that means that there's also no amplitude. And just to finalize this graph out, I would say, y'all, take a look at this. This is what it looks like when you get the whole thing graphed out on the whole 4 periods worth on this paper. So definitely pause the video, get this filled out for me, and then come back when you're ready to move on to our handwritten notes. We've got we got an example we're gonna do. All right, so we're gonna look here at cotangent. Again, just like we did on the tangent ones, this is just an added bonus for what the function can look like. And if I was going to graph it by hand, this is usually what I do on notebook paper. I just make it look like this. I do show the values where it's going to hit the x-axis or where the asymptotes go through. Try to find those, label the important values. Sometimes we get a little bit lazy with our graphing and we just want to copy what our calculator looks like. But that's not really truly graphing it. So make sure that you include points, plot them, and they're going through the correct values. All right, so this example right here with cotangent, they ask us to find they said to describe it, locate the asymptotes, and then graph 2 periods worth. So that's what we are going to do here. All right, so with this, I see that I'm going to compare this to the parent function, which is just a plain old cotangent, right? There's actually 3 things going on with this function right there. Those values are that that 3 in the front is going to vertically stretch it. Or you could say dilation. Nope, not 2, 3. Okay, so that's your vertical stretch or dilation, right, of 3. We also have this value that is with the x that indicates a horizontal change. So you can think of what value is multiplying by x here, and that's 1/2 times x to get you x over 2. So really this is a horizontal, we could say dilation, or this will actually be a stretch if we're trying to be specific, Because remember that with horizontal stuff, you have to flip it. So although this value, the factor in here is 1/2, when you talk about the horizontal dilation, you have to flip it. So it's actually 2/1, 2. We also have this shift up. So there we go. All right. Then we're going to, they said locate the vertical asymptotes, graph the two periods. There's also another description I can give. A really defining feature about our trig functions is what the period is. This period is not going to be the same as the parent because it's been horizontally dilated. So let's talk about what that period will be. If it's had a horizontal stretch dilation of 2, my period is not going to be pi anymore. You're going to take that period and multiply it by that horizontal dilation factor. So instead of pi, it'll be 2 times pi, which is just 2 pi. So it's going to take longer to get through. That's why they're only wanting 2 periods worth, is because that horizontal distance is going to be larger. Okay. So let's make this be like 2 pi over here. This would be pi. Let's make this negative 2 pi, negative pi. All right. And remember with cotangent function that you end up with an asymptote on the y-axis, assuming that it's not shifted left or right. And this has not been shifted left or right. It was shifted up, but not left or right. So we will have an asymptote that goes on the y-axis. We're also going to have one at the end of the period, so at 2 pi. And we'll have one at the end of this period, so at negative 2 pi. That will encompass my 2 periods. Okay, so that right there helps me figure out that horizontal stretch pretty well. Another thing that we've got to look out for, though, is that this has been vertically shifted up 1 unit, which means instead of me hitting the x-axis at negative pi and at pi, it's actually going to go through this value 1 right there. It has not been reflected, so it's going to be facing the same way cotangent is supposed to. And honestly, this is enough for me when you guys are graphing this stuff, okay? You've labeled some things. You're showing me that this is not hitting the x-axis at those pi values. It shows me that you understand this well enough to graph this without the calculator. They did ask about the asymptotes, so let's look at what these asymptotes have in common. 2 pi, 0 pi, 2 pi. If you can imagine the next period over, it's going to have another asymptote at 4 pi, 6 pi, 8 pi. So all of my asymptotes are at even multiples of pi. All right, so that is a nice little description there. All right, y'all, we are going to pause here. In the next video, we're going to try to cover secant and cosecant in the same one. So stay tuned for that. I'll see you on the next video.